Have you ever felt like you're stuck in a stuffy house, but you're afraid to open a window because of the heat, cold, or pollution outside? What if you could have a constant supply of fresh, clean air without sacrificing an ounce of energy? If you're building a passive house or any ultra-tight home, ventilation is not optional. It's almost mandatory. In today's video, we're diving deep into the technology that makes this possible, especially for some of the most energy-efficient homes in the world, passive houses. We're talking about the unsung hero of indoor air quality, the Energy Recovery Ventilator, or ERV. What is an ERV? An ERV, Energy Recovery Ventilator, is a balanced ventilation appliance with two fans and a heat and moisture exchange core. One fan exhausts stale indoor air. The other supplies filtered outdoor air. Inside the core, heat and some moisture transfer between airstreams without mixing the air itself. The result: constant fresh air, tempered close to room conditions, with controlled humidity, even in tough climates. Cores come as enthalpy, ERV, or sensible, HRV. Passive house in mixed, humid climates typically uses ERV to manage moisture. Why ERVs are essential in passive house? Passive houses are built with an almost airtight envelope. This extreme airtightness is fantastic for energy efficiency. It's how they dramatically reduce heating and cooling costs. But it creates a new challenge. Without uncontrolled air leaks, you have no natural way to exchange air. Common indoor pollutants. Biological contaminants: carbon monoxide, indoor particulate matter, indoor microbiome, mold and moisture, nitrogen dioxide, pesticides, radon, secondhand smoke and aerosols, volatile organic compounds. Deficient IAQ can lead to health problems, cognitive impairment, and reduced productivity, costing the U.S. economy billions annually. Contaminants in indoor spaces come from construction materials, furniture, cleaning supplies, and even occupants themselves. ERV is the only way to ensure consistent, healthy indoor air quality. It provides controlled ventilation, guaranteeing a continuous flow of fresh, filtered air while maintaining the home's impressive thermal performance. Without an ERV, a passive house is nothing more than a well-sealed container of stale air. ERVs help manage indoor humidity and improve IAQ with MERV-rated filtration. Passive house guidance targets high heat recovery efficiency and low specific electric power for the unit. ERV transfers heat and moisture. HRV transfers mostly heat codes and standards you need to know. ASHRAE 62.2, Residential Ventilation. ASHRAE 62.2 is a minimum national standard that provides methods for achieving acceptable indoor air quality in typical residences. It was developed and is maintained by the American Society of Heating and Air Conditioning Engineers. ASHRAE sets the whole house required ventilation rate. The common form is roughly area plus people. The whole house ventilation rate is often calculated using the following formula: 0.01 * square footage plus 7.5 * number of bedrooms plus 1. Whereas, whole house ventilation means exhausting stale indoor air and replacing it with fresh outdoor air. Kitchen: 100 CFM intermittent or 5 CFM continuous. Bath: 50 CFM intermittent or 20 CFM continuous. IRC, IECC. Most jurisdictions require a dwelling unit mechanical ventilation system meeting 62.2. Many require airflow verification at the register and fan efficacy compliance. 2021 IECC requires testing of whole house ventilation and fan efficacy compliance. Some provisions require HRV, ERV in very cold zones. 7-8, balanced packaged HRV, ERV systems are expected to comply with HVI 920 and be tested so you can commission to the required CFM. Certification expectations for ERV. FEAS. FEAS requires an ERV to have a high-efficiency core and a low fan energy consumption rate, often aiming for less than 0.7 W/CFM at its design airflow. The unit must also have a certified sensible recovery efficiency and latent recovery efficiency. Use FEAS-adjusted HVI winter ratings for accurate modeling. Place the ERV inside the thermal envelope and balance at design static pressure. LEED version 4.1 residential. Minimum IAQ performance requires a dwelling unit ventilation system that complies with ASHRAE 62.2 2022-2019 sections for design and operation, or a stricter local code. Under LEED version 4.1 for homes, using a balanced ventilation system with heat or energy recovery, like an ERV, is a credit-earning strategy, especially for projects seeking higher levels of certification. Net zero targets. Not a code by itself, but ERVs are often mandatory in the energy model to hit site or source EUI goals because they cut ventilation heating and cooling loads. 2021 IECC already nudges you there with efficacy and verification. Real models that work: single family, townhomes, multifamily. Here are North American models with the specs you'll actually use. I'll give the low, high CFM and a practical W, CFM at a published rating point. Remember, W, CFM varies with static pressure and speed. Use the project's design point. Manufacturer model, example. Design and install tips that avoid callbacks. Keep the ERV inside the thermal air barrier to reduce losses and protect it from freezing. Use short, smooth, large radius ducts and balance at the installed static pressure. Size from the ventilation rate first, then confirm recovery efficiency and W, CFM at your external static. Filter both supply and exhaust to protect the core. Verify frost control strategy for your climate. For centralized MF, specify balanced ventilation and maintain CFM to each unit. Many jurisdictions are writing balanced, distributed systems into local mechanical code. Hollow square with rounded corners. The ERV, HRV shall either be connected to the central air handler and use the HVAC ducts for supply air, or have its own independent supply ducts. Return air intakes can either be individually ducted from several rooms or ducted from one or more central locations, or the ERV, HRV can use the HVAC system returns. It is recommended that each occupied room with a door have at least one ducted supply, or one ducted return, or both. Hollow square with rounded corners. An HRV, ERV that is connected to the central system supply side shall have a damper to keep air from flowing backward through the unit when the ventilator is off. Each occupied room should have one ducted supply or return or both. Hollow square with rounded corners. Outdoor air shall be filtered with a MERV 11 filter or higher, and the pressure drop across the filter shall match equipment capabilities. The filter shall be installed to be easily accessible by occupants. Hollow square with rounded corners. The fan shall be oriented so the equivalent length of the duct run is as short as possible. Equivalent length shall be calculated in accordance with ANSI, ACCA Manual D. Residential duct systems. Hollow square with rounded corners. The exhaust duct outlet vent shall be located on the exterior of the home where it does not direct airflow onto a walkway, and it is situated at least 10 feet from any air inlet. Hollow square with rounded corners. Outdoor air intakes shall be equipped with screens to keep out insects and debris, integrated with siding including flashing required to prevent water intrusion, and sealed with caulk or spray foam where the edges of the duct meet the exterior walls or ceilings to limit the infiltration of exterior air into the home. Hollow square with rounded corners. All duct seams and connections shall be sealed with mastic or UL 181 tape. Hollow square with rounded corners. Ducts installed outside of the thermal envelope shall be insulated to a minimum of R8. Conclusion: ERVs make passive house ventilation practical. Balanced air, high recovery, and controlled moisture. Pick a unit with proven ratings, low W, CFM at your design point, and commission it to the code ventilation rate. Your clients get quiet, clean, comfortable air year-round. What are your thoughts on ERVs? If you find this video helpful, give it a thumbs up and subscribe for more content on building science and home performance. Let me know in the comments below. Thanks for watching.